I'm Luke.
I'm Alan.
I'm Ella.
And today we're doing a mole video about converting molecules to formula units and finding percent composition. I found that there was a mole day on October 23rd, and a mole is a unit of measurement described as that number there.
Hi, my name is Ella, and I'm going to show you how to convert mass to molecules. So the compound we're going to be using today is HCl. So the first step of trying to find mass to molecules is first we're going to find the atomic mass of the compound. Then we are going to plug in all of our numbers to the formula, which I'll show you how to do. Then we're going to multiply, and then our last step is divide, and after that we'll get our answer. So it'll all make more sense when I show you how to do it. So, like I said, our first step is to find the atomic mass of HCl. So we're going to basically divide this up. So first, we're going to take H. So on your periodic table, it will show what the atomic mass is. It's normally a decimal. So the atomic mass of hydrogen is 1.008 grams. Okay. Then you're going to go to chlorine, and the atomic mass of chlorine, or you can also call it molar mass, is 35.45 grams. So, since it's a compound and they're together, and normally there'll be a subscript, so maybe like a 2, and if there's a 2, like right here, you're gonna multiply it by 2, but for this problem, there's not, so you don't have to worry about it. So, 35.45 grams. So then you're going to take these two atomic masses and you're going to add them together, and you're going to get 36.46 grams. And this is a number that you're going to plug into your formula. So we're going to erase that. So the problem says how many molecules in a 6.3 gram sample. So 6.43 gram. Now, this is important because this is one of the main factors you have to plug into your formula. It's just a given number they give you. So first you're going to write this number, so 6.43 grams, and make sure you put this because it's important. It's a neat way to keep everything organized. And you're just going to put it over 1. Then you're going to do times 1 mole, and this is a mole too, over 36.46 grams of HCl. This is the atomic mass that we found from HCl, so you're going to plug it in down here. And why you put this here and this here, because you always put the number that they give you in the problem first. Then you always put the atomic mass that you find. So since we're not finding mass, we're going to cross these out because they're diagonal from each other, so we can get to molecules. So after that, we're going to times it again by a number 6.022 times 10 to the 23rd molecules. And the reason why it's molecules is because we're finding it, and then you're going to do it over 1 mole of HCl. So this number is basically, it equals 1 mole. It's the equation of a mole. And so you see we have a mole right here, and make sure you put HCl, and you have 1 mole right here, so you're going to cross those out, and now you're left with molecules, which is great. That's what we want to find. So after you multiply the top, you're going to get 3.87 times 10 to the 24th, and you keep this number, you don't multiply it, it's a number that stays like that. So since you're just multiplying by 1 on the bottom, you're just going to put 36 0.46 gram 46. Okay, so then you're just gonna divide this, and you're going to get, I'm gonna make some room. You're gonna divide, and your answer for the problem is going to be 1.06 times 10 to the 23rd molecules. And make sure you put the molecules, because if you're taking a test or anything, you're gonna get points taken off. So now we're gonna do an overview of what we did. So again, the problem stated the compound HCl, and it was a 6.43 gram sample of it. So you need to find the atomic mass, which was 36.46 grams. And then you need to take this and plug it into the formula. And remember, it's important that you need to put like a gram right here. So a gram over 1 and another gram right here, so they cross out. Then you're gonna put a mole right here, and you're gonna multiply it again, and you're gonna put a molecule, because this one you don't want to cross out with any of them because that's a part of your answer. Then you're gonna put mole, so they cross out. You gotta remember that. So we did that, and we got 3.87 times 10 to the 24th over 36.46, because remember, the bottom had 2 ones in this number, so it's just gonna be the same number. So remember, we divided again, and our answer comes out to be 1.06 times 10 to the 23rd molecules. So that's how you convert mass to molecules.
Hi, my name is Alan, and today we're going to find the percent composition of PB, open parenthesis, ClO2, close parenthesis, 2. And how we're going to do that is using a specific formula. This formula is the number of atoms multiplied by the atomic mass all over the atomic mass of the whole compound. All multiplied by 100. And for these two, you'll have to multiply the atoms and the atomic mass. It's for a specific element that you're trying to find in the compound. So how are we going to do this is in a couple of steps. So step 1, find your info. So in other words, find your number of atoms, find the atomic mass of your elements, and then find the atomic mass of the whole compound. Number 2, plug in your info. So once you do that, you'll solve the formula or each element. And then the final step is once you find each element's percent composition, you'll add each element's composition to get the compound's composition, percent composition. So how we're going to do that is find the percent composition of the element lead, or in this case, PB. How you're going to do that is find the number of atoms, which is 1, multiplied by the atomic mass, which is 207.20, all over the atomic mass of the whole compound, which is 258.65. all multiplied by 100. What you want to do is multiply this 1 times 207.20, and you will get 207.20 all over 258.65 multiplied by 100 still. This divided by this number, you will get 0.801 multiplied by 100. Once you do that, you will get 80.1. But you do not want to have a decimal in your percent composition, so it will just be 80%. That's how you find it for PB. So for the next element, we need to find chlorine. So what we need to do is find the number of atoms, which how you're going to do that is look right here, and there's not really a number here, so you'll just count that as 1. You'll have to multiply this 2 on the outside. So it would just be number of atoms is 2 times the atomic mass, which is 35.45 all over the atomic mass of the whole compound, which is 258.65 multiplied by 100. What you want to do is multiply this 2 by this 35.45, and you will get 70.9 over 258.65 times 100. And we'll divide the 70.9 divided by 258.65. So what you also want to do, once you get this answer, which is 0.274, multiply that by 100, and you will get 27.4. But you're not done yet because you still do not want a decimal in your final answer, so you will round it down to 27%. And now we need to find the percent composition of oxygen. And what we're going to do is find the number of atoms. You see how it has a 2 right here. You have to multiply that 2 by this 2. You will get a 4 for the number of atoms, multiplied by the atomic mass, which is 16, all over 258.65 times 100. So you want to do the first 4 times 16, which is 64, all over 258.65 times 100. And you want to divide 64 divided by 258.65, and you will get 0.247 times 100, and you will get 24.7. But still, you do not want a decimal, so you will round that up to 25%. So after you've gotten this 80%, 27%, 25%, you'll need to find the percent composition of the whole compound. So how you're going to do that is take that 25, 27, and 80 and add them all together to get your whole composition of your compound. So you will get 80 plus 27 plus 25, which equals up to 132. So your percent composition of your compound equals up to 132%. So in conclusion, or in a summary review, you will need to find your information. So in other words, find your number of atoms and your atomic mass. You need to plug in your info, which is where you get this, and then you'll need to solve for your formula of each element. So you'll plug in and then solve this formula, and then add each element composition to the compound for the compound composition, percent composition. which is 80, 27, 25. And that is how you get 132.